So unfortunately, my recording cut me off earlier, but let's pick off from where we left off. So we found the side length of ABCD, which means, and so to conclude, the side length of ABCD are, not is, are root 17. So that's for this side, plus another root 17 for this side, and plus root 10, which is the top here, here. So plus root 10, and plus another root 10, which is the bottom length here. And that can be simplified to just, let's see, these two are like terms. Root 17 plus root 17, that would be 2 root 17 plus the root 10 here and root 10 here are also like terms, and that would be just 2 root 10. And let's just say units. So yeah, that is the side length of ABCD. Now, let's move on to the last part of the question. Let's determine the area of parallelogram ABCD, and we need the final result corrected to the nearest tenth. So to find the area of a parallelogram, we know that the formula is, area is equal to the magnitude of the cross product of vector A cross product of vector A and vector B. So that's the area of a parallelogram. And so, what is vector A and vector B? Well, let's draw it out. So when we're talking about an area of the parallelogram, we're essentially picking this side here and this side here, and vector A should be the combined vector of from here to here. And vector B should be the combined vector of the point here to here. So this is just the general, diagram. And then if we want to, modify it in relation to our question here, we know that this corner should be A, and then that corner should be D, and that corner should be B. So in our case, our vector A should be the vector of AD, and our vector B should be vector A to B, capital A to B. So yeah, now that we have that, we can solve for our area. So we know that our area is equal to the magnitude of the vector AD crossed with vector AB. Now let's break this down. First, let's find the cross product of vector AD and vector AB. So vector AD crossed with vector AB. So we know from earlier that the vector AD has a coordinate of -3, 0, 1. So let's write that down. -3, 0, 1. And then we also found earlier that the vector AB has the coordinates of, where was it? Here it is, 3, -2, and -2. So let's write that. So 3, -2, and -2. And now to solve for this, let's use the shortcut that we learned in class. So basically we want to, I'll just write it out, but we take the y value of both. So by y value of the first one, the y value of the second one, we have 0 and -2. The z value of the first one and the z value of the second one, so 1 and -2. the x value of the first one, the x value of the second one, -3 and 3. And then, once again, the y value of the first and the y value of the second, which is, once again, 0 and -2. And then over here, we just want to cross them, as in cross multiply. So what we have here is, so essentially what we did here is we want to take these two, we multiply them together, and then we add to this the product of these two. So 0 times -2, that is 0. Or sorry, we don't want to add them, we want to subtract them. So 0 times -2, that gives us 0. And then that is, we subtract that by 1 times -2, which is -2, so subtract -2. Now moving on to the next one, so 1 times 3, that is 3. Subtract the product of -3 and -2, which is 6. So subtract 6. Sorry, it's so hard to see. Now the last one, -3 times -2, that is also 6. And then that subtract the product of 0 times 3, which is just 0. So 0. And then simplifying these, we have the cross product of vector AD and vector AB would be 0, subtract -2, which is just 2. 3 minus 6, -3. 6 minus 0, which is just 6. So here we have the cross product. And now we need to find the magnitude of the cross product. So let's write that. Magnitude of vector AD cross vector AB. That'll be the whole thing square rooted. And then we take the x value and then we square it, plus the squared value, y squared, and also plus z squared. And that should give us, so this would be 4 plus -3 squared, which is 9, 4 plus 9, that is 13, and then we have 13 plus the 6 squared, which is 36. So 36 plus 13, that should be 49. And here we have the square root of 49, which we know is 7. Yeah, we found our answer. The area of the parallelogram is, the area of parallelogram A, B, C, D is 7 units squared. And yeah, this is our entire question completed.